Our universe is constantly expanding, which makes it incredibly challenging to determine its boundaries or measure its full size. However, with the help of the James Webb Space Telescope, we are now able to peer deeper into the cosmos than ever before. Since the telescope began its mission, scientists, including Brian Cox, have made astonishing revelations about the scale and immensity of the universe, which is almost beyond comprehension. Within the observable portion of the universe alone, there are an estimated 2 trillion galaxies, a figure based on studies of our local universe. Yet, we're confident that what we can observe is just a small fragment of what might be an infinite cosmos still beyond our reach. We are not separate from this universe. We are an inseparable part of it. In a profound way, we are how the universe becomes aware of itself. Thanks to the James Webb Telescope, we've embarked on a journey to uncover the true scale of existence. If you're fascinated by discoveries about the universe and beyond, make sure to subscribe to our channel, like this video, and turn on the notification bell to stay updated. To better grasp the vastness of even our own solar system, consider this. Traveling at just 70 miles per hour, it would take roughly 15 days to circle Earth's equator. At the same speed, it would take about 5 months to reach the moon, 63 years to get to Mars at its closest, and nearly 4,400 years to reach Neptune. For added perspective, the Voyager 1 probe, launched in 1977 at 38,000 miles per hour, only exited the solar system in 2012, 35 years after its launch. Even light, which can circle the Earth 7 times in a second, seems slow when we consider the distances involved. Yet, our solar system is tiny compared to the Milky Way galaxy, which contains roughly 300 billion stars, most with their own planetary systems. Our nearest neighboring star system, Alpha Centauri, is 4.3 light-years away. Traveling at the speed of light, it would take 4.3 years to reach it. But if we traveled at Voyager 1 speed, it would take about 70,000 years to get there. These staggering numbers highlight the true scale of cosmic distances. Now, let's turn our gaze to Velta Rouge, a star located 640 light-years away. The light we see from it tonight actually left the star's surface 640 years ago, around 100 years before Columbus set sail for the New World. That light has journeyed across space for centuries just to reach your eyes tonight. Consider the radiosphere, the bubble of space that encompasses all radio transmissions made by humanity over the last century. Even though the signals degrade over distance, they've reached roughly 15,000 star systems. But in comparison to the hundreds of billions of stars in the Milky Way, that's only a tiny sliver. And yet, Velta Rouge is still relatively close by universal standards. To illustrate the scale, if we shrank our entire solar system to the size of a quarter, the Milky Way galaxy would be the size of the entire Earth. Within that galactic, Earth, there are 300 billion other star systems. Ours is just one among them, floating in an ocean of stars and planets. Beyond that, at least 1 trillion more galaxies. Yes, 1 trillion, an almost unfathomable number. To put in perspective, imagine 1,000 cats. Now imagine 1,000 groups of 1,000 cats. That gives you 1 million cats. But 1 trillion is 1 million times 1 million. That's 1 billion groups of those cat gatherings. Finally, our closest galactic neighbor is the Andromeda Galaxy, another enormous stellar system that helps put our place in the cosmos into perspective. In this grand universe, we are but a single flicker of light, small, yet part of something magnificently vast. The galaxy Andromeda, located about 2.5 million light-years away, is rapidly moving toward us at an incredible speed. As it approaches, our night sky will experience notable changes. This galaxy contains roughly 1 trillion stars. When it eventually collides with our own Milky Way galaxy, which has about 300 billion stars, the likelihood of individual stars from both galaxies colliding is very low. This highlights the immense scale of space and the rarity of direct star-to-star encounters within galaxies. Though collisions between stars are rare, galactic mergers can still play a significant role in shaping the cosmos and possibly even fostering life across galaxies. Galaxies are not fixed. They are dynamic and constantly evolving systems. Beyond our Milky Way lies a local group of galaxies, which is followed by the Virgo cluster, containing over 1,500 galaxies. The Virgo cluster itself is part of a larger supercluster called Laniakea, which houses around 100,000 galaxies, each with hundreds of billions of stars and planets. And this represents just a tiny fraction of the larger universe. Within the observable universe, there are roughly 10 million similar superclusters. As we observe further, the number of mapped galaxies continues to grow. However, these mapped galaxies only account for a small portion of the total, as hundreds of billions of galaxies remain unmapped. Additionally, the cosmic microwave background radiation represents the oldest detectable light, the leftover heat from the Big Bang, offering a glimpse into the universe's earliest moments. The universe's scale becomes even more astonishing when we consider the vast expanses beyond galaxies, such as cosmic voids. These enormous regions, spanning hundreds of millions of light years, contain very little matter and appear as vast empty spaces. Despite their emptiness, cosmic voids may eventually give rise to new galaxies and structures. Further out, we find cosmic filaments, gigantic strands of dust, gas, and dark matter stretching billions of light years. These filaments connect galaxies and galaxy clusters, forming a vast cosmic web that holds the universe together through gravity. Matter in the universe is distributed unevenly, creating a network where clusters and superclusters link via these filaments, weaving an intricate cosmic tapestry across unimaginable distances. Within this grand structure, galaxies congregate and interact gravitationally. Space is a vast arena filled with countless celestial phenomena. For example, supernovae, the explosive deaths of massive stars, scatter heavy elements throughout the cosmos, enriching star systems and planets. Black holes, with their tremendous gravitational pull, influence galaxy evolution and can emit powerful jets extending far into space. We also find exotic objects such as quasars, supermassive black holes that consume matter intermittently and release enormous amounts of energy. Quasars can outshine entire galaxies and serve as beacons from the early universe, helping us understand its formative stages. But what lies beyond the observable universe? Many galaxies exist beyond the reach of our current vision, as their light has not yet arrived at Earth. Due to the universe's ongoing expansion, much of the light from these distant galaxies may never reach us, rendering those regions forever inaccessible. By applying the laws of physics, scientists estimate that the entire universe is at least 250 times larger than the portion we can observe. The universe is incredibly vast. So vast, in fact, that some compelling arguments suggest it might be even larger than we imagine, potentially infinite. This perspective invites us to think deeply about the nature of the universe and our place within it, as human beings residing on a small, remote planet in the vastness of space. Reflecting on these possibilities encourages us to consider our existence and the roles we play in the cosmos. Have you ever wondered just how immense our universe really is? If so, I hope this video has helped you grasp a bit more of its incredible scale. Feel free to use the comment box below to share any questions you have. And if you enjoyed the video, please hit the like button, share it so it reaches more people, and subscribe so you don't miss out on future content like this. Thanks so much for watching, and see you in the next video. As we continue exploring the cosmos, it's important to remember that our understanding of the universe is always evolving. New instruments, like the James Webb Space Telescope, have opened doors to discoveries once thought to be purely science fiction. These powerful tools allow us not only to glimpse the early universe, but also to study the atmospheres of distant exoplanets, bringing us closer to answering one of humanity's greatest questions. Are we alone in the universe? In recent years, astronomers have identified thousands of exoplanets orbiting distant stars. Many of these lie within the habitable zone, where conditions might allow liquid water and possibly life to exist. Some are Earth-like in size and composition. Others are gas giants or icy worlds with subsurface oceans. With billions of such planets estimated to exist within our own galaxy alone, the condition for life may be far more common than we once believed. Beyond the search for life, the universe itself holds countless mysteries. Consider dark matter and dark energy, which together make up about 95% of the universe's total mass energy content. Dark matter, which influences the movement of galaxies through its gravitational pull but emits no light, helps shape the cosmic web. Dark energy, meanwhile, is thought to drive the accelerating expansion of the universe. Despite their massive influence, both remain largely theoretical and have yet to be directly detected. There's also the intriguing concept of the multiverse, an idea some physicists propose that suggests our universe might be just one among an infinite number, each with its own physical laws, dimensions, and possibilities for life. These other universes could be completely separate from ours or exist in higher dimensions, accessible only through advanced mathematical theories or quantum phenomena. While still speculative, this idea broadens our perspective on what might lie beyond our cosmic horizon. Time itself is relative in the universe. According to Einstein's theory of relativity, time slows down near massive objects, a phenomenon known as gravitational time dilation. This means that time on a space station orbiting close to a black hole would pass more slowly than it does here on Earth. This mind-bending concept has been experimentally confirmed and has profound implications for space travel and our understanding of space-time. Black holes are not merely cosmic vacuum cleaners. They are engines of extreme physics. At the heart of nearly every large galaxy lies a supermassive black hole, with masses millions or even billions of times that of our Sun. These giants influence galaxy evolution, regulate star formation, and sometimes shoot out powerful jets of energy that stretch across entire galactic arms. Even more exotic are wormholes, hypothetical bridges through space-time that could, in theory, connect distant parts of our universe or even different universes altogether. Though still theoretical and faced with stability challenges, wormholes remain a captivating subject in both science and science fiction. Yet despite all this vastness, complexity, and awe-inspiring scale, here we are, a species on a small rocky planet orbiting an ordinary star in a quiet corner of one galaxy among trillions. And still, we are capable of asking these profound questions, building instruments to explore the stars, and imagining realities far beyond our immediate reach. Every image sent back from a space telescope, every faint radio wave traveling across light years, every particle detected in underground labs, all these are pieces in the puzzle that help us understand the cosmos. So, when you look up at the night sky, you're not just seeing distant points of light. You are gazing into the past, into the very structure of space-time, into mysteries yet to be unraveled. The universe is not only vast, it's a mirror reflecting our boundless curiosity and unyielding desire to know.